Okay, I'm going to start working on the answer keys for the practice test for stoichiometry. We'll start with question number 1. What is the molar mass of magnesium? So you got to take a look at your periodic table. You find magnesium, it's atomic number 12, and it's just listed as 24.31. So it's going to be, whoa, no, that's not that. It's going to be 24.31 grams per mole. And I just pulled that off the periodic table. What is the molar mass of Fe2PO3? Okay, so let's do it this way. You find iron and it's 55.85, so 55.85, and you got 2 of those. Phosphate, P is 30.97, so 30.97, and then we got 3 oxygens, and each oxygen is 16, so 3 times 16 is 48, so I'm just going to save that step, so plus 48. All right, so this is the P, this is the P, and this is the O3. And we got 2 of those. And then we just add those 2 things together, right? So now it's calculator time. We're going to go 55.85 times 2 plus, looks like 78.97 times 2. You got to use the parentheses correctly on your calculator, otherwise the terms will get distributed wrong and you're going to get it wrong. So you just got to make sure you use parentheses correctly. And you get 269.64. So 269.64. Okay? Grams per mole. What is the molar mass of ammonium carbonate? All right, same deal. Let's do 2 ammonium. So nitrogen is 14.01 plus, now each hydrogen is 1.01, so I'm just going to multiply that by 4 in my head. That's 4.04, so 4.04. And this is going to be times 2, because we got 2 of them. And then we got a carbonate, just a single carbonate, and so this is going to be 12.01 plus, that's the carbon, and then the oxygen is 3 times 16, so that's 48. And again, just got to make sure you do the parentheses correctly here. So 14.01 plus 4.04, that's 18.05 times 2, plus 12.01 plus 48, and that's like 96.11. So 96.11. I guess let's take that. We got a little tiny little. Whatever. You know what? Whatever. Whatevs, as I used to say when I was in high school. All right, let's jump down to question 4. How many grams are in 25.5 moles of sodium hydroxide? So we got to figure out the molar mass of sodium hydroxide. Sodium is 22.99. Oxygen is 16. Hydrogen is 1.01. So let's just add up all those things together, and I can tell already it's going to be an even 40. So a single mole of this stuff weighs 40 grams. You got 25.5 moles of it, so it's going to be 40 times 25.5. Makes sense, right? So 40 times 25.5, 1,020. So 1,020 grams. Question 5, how many moles are present in 100 grams of water? All right, so again, we got to figure out the molar mass of water. Water is H2O. So that is, we got 2 1.01s, that's the H2, plus the 16 even, which is the O, and that's 18.02. Okay. So water is 18.02 grams per mole. We got 100 grams of it. So if you wanted to write this one out, you could go like this. I mean, if you wanted to do it this way. And the molar mass is 18.02 grams for every mole. And so it's 100 divided by 18.2. So 100 divided by 18.2. 18.02, I'm sorry, 18.02. 5.55 moles. So 5.55. Question 6. The 7.76 moles of carbon dioxide would be how many grams? Again, this is yet another one where we need the molar mass of carbon dioxide. So that's going to be 12.01 plus 2 times 16. So That's going to be 32 plus 12.01. That is 44.01. So 44.01 grams per mole. That's carbon dioxide. We got 7.76 moles of it. So again, if you wanted to write this whole thing out, you could do it this way. 1 mole of CO2 is 44.01 grams. And you can see that you're multiplying. So 7.76 times 44.01, 341.52 grams. I can see my time is just under 6 minutes, so we will keep going. So question 7, which of the following is a true statement for the following chemical reaction? So notice that you can look at all these questions have to do with product. So we're trying to identify which are reactants and which are products. Sodium bromide. This is sodium bromide right there. It's a product. No, it ain't. All right, because reactants are on this side, and products are over here. Products are what you make, right? Hydrogen is a reactant. No, it ain't. It's a product. Fake, false. Water and sodium bromide are reactants. So water and sodium bromide are reactants. That's true. Woohoo! And bromide and water are reactants. That's wrong. That's obviously wrong. So yeah, water and sodium bromide are reactants. That's true. What are the correct coefficients for the following unbalanced chemical reaction? Okay, so we can do a little RP table. Whoop, whoop. We got irons. We got, oh, this can be easy. On the reactant side, we start with 1 of those, 2 of those. On the product side, we start with 2 of those, 3 of those. And, well, let's try to get the oxygens to match. We got 2 and a 3. The only number that, the lowest common denominator is a 6. So let's just start with that. So if we put a 2 here and a 3 here to get both of these things to be 6, that leaves us here with 4. And now we just got to make sure that the irons match. It looks like 4, 3, 2. Boom. We got that as an option. So, yeah, we're still cruising. What are the correct coefficients for the following unbalanced? Oh, another one. All right. So, again, let's do another little RP table. Whoop, whoop. We got potassium, we got oxygen, we got hydrogen, and we got PO4s. We're going to keep the PO4s together because they appear on both sides. And we're keeping it separate from the oxygen right here just because it's, you know, PO4, that's not the only O. There's an O there and an O there, right? So I'm just going to keep these things separate. Oh, my goodness. There we go. So let's just count them up. On this side, we got 1 of those, 1 of those. We got 4, right? So we got 1, 2, 3, 4. So 4 hydrogens, and we only got 1 phosphate. On the other side, we got 3 of those. We got 1 phosphate, that's that. We got 2 hydrogens and a single oxygen. So we got to figure out a way to get this thing to match. So I'm just going to erase my little work right there. Looks like the easiest first step would be to put a 3 right here to get the potassiums to match. And then let's just see what happens. So that turns this into a 3. This turns this into a 3. This turns this into a... Well, now we have 3 here, and we still have 3 there. That turns this into a 6. All right. So well, then let's continue to see what happens here. So if we want to get the... hold on 1 second. Oh, that's... I noticed that for some reason I have a 0 there. I'm just going to put a 1 right there. Maybe that was a sloppy one. Anyways, so we're trying to get the, let's see here, the H's to match. Let's do the O's, the single O's. Let's put a 3 right here. See what happens. Again, I don't know that this is the way to do it, but if it isn't, I'll probably just delete this section and redo it. So we've adjusted, so now we have 6 H's on this side, and then we got 3 single O's. Wow, that's, okay. Well, it looks like that's it, because these all match already. I thought there would be more steps to that one. So it looks like we have a 3, 1, 1, 3. Is that an option? It is. 3, 1, 1, 3. Okay. Looks like we're at 10 minutes right now. So I'm going to do one more of the coefficient one, and then we'll stop this video. So what are the correct coefficients for this one? And then again, another RP table. Whoop, whoop. And we've got N's, we got H's, and we got O's. And that's it. So it shouldn't be too hard. We got 1, 3, 2. On the product side, we've got 1, 2, 2. So let's figure out a way to make these things match. Let's start, well, with the hydrogen, notice that the hydrogens come in bundles of 3 here, bundles of 2 here. Let's find a lowest common denominator there to make these things work, and that would be 6. So I'm going to try that real quickly just to see if this will turn out. 2 here, and let's put a 3 here. So what this does is this turns into a 2, this turns into a 6, this turns into a 6, and this turns into a 4. Alrighty. Now, in order to get the nitrogens to match, if I put a 2 right here, that turns into a 2. But now you notice that we got an odd number of oxygens, right? We're going to end up we got then 2 oxygens here, we got 3 there, we end up with 5 over here. All right, so I can tell already just from experience that if I try to match with 2s, it's not going to work because you're going to have this constantly even odd problem. So what I'm going to do is, it looks like 2 is not going to be the way to go, and I'm going to quickly try making these things to be 4. So let's do this. Nitrogens, instead of going 2 and 2, let's go 4 right here and 4 right here. So that makes this 4, that makes this 12, and that makes this 2. That makes this 4, that makes this still 2, and now we've got 5 right here. And looks like we got a 4 here, so let's just, this could be this one. So let's just double check. So this looks like this is the only one that could be this first one right here, so let's just check it. Let's just see if it works. So 4 to 6. Or sorry, 5 and a 6 here. So let's add them up. So if we do it this way, now we have 10 oxygens here. If we go to this one, we've got 12 hydrogens, and then 4 oxygens and another 6 would be 10 right here. Okay, so it looks like this will work just fine. So I do want to point out too that with these coefficients, when you're trying to figure these out, you could always just you could always plug in the first one, see if it matches. If it doesn't, try the second one, see if it matches. You don't have to solve it yourself. You could always just do guess and check what the answers they provide. But anyways, in this case, it turns out to be the first one. Looks like that's it for my time on this one, because YouTube limits me to 15 minutes, so I will do the last 4 on the next video.